Hi everyone, I hope you're okay. This is video number 7, guys, which simply means I'm doing the seventh question from the November 2023 Physical Science Paper 2. If you are new to the channel, guys, and this is the first video you come across, please note that there are 6 videos before this one, and you can just download the paper, answer the questions with me. If there are things I'm not happy about, do write on the comment section. I'll definitely attend to you. Before we even start, guys, please don't forget to subscribe. Your likes and any form of engagement, guys, will help us grow the channel, and maybe we can reach a lot of students before they even write, and they can learn a thing or two, just to make sure that they are fully prepared. Okay. Question 7. To identify metal X in an unknown metal carbonate, the following procedure is carried out. Okay, step number 1. There is 0.198 grams of impure M carbonate. This M carbonate is reacted with 25 cubic centimeters of 0.4 moles per cubic decimeters of nitric acid. Okay, and then the excess nitric acid is then neutralized with the 20 cubic centimeters of 0.15 mole per cubic decimeters of barium hydroxide. Okay, assume the volumes are additive, number 1. Okay, the following reactions take place. We have nitric acid reacting with the metal carbonate, okay, forming the metal nitrate plus carbon dioxide and water. Then secondly, the excess nitric acid reacts with barium hydroxide, forming barium nitrate and water. Okay, firstly, we are supposed to define the term strong base. A strong base is a substance that dissociates completely in water to produce a higher concentration of hydroxide ions. A strong base is a substance that dissociates in water to produce a higher concentration of hydroxide ions. Okay. 7.2.1, we are told to calculate the number of moles of barium hydroxide that needed to react with excess hydrochloric acid. Okay, the number of moles, I know that concentration is always equal to N multiplied by V, right? I am given the concentration of my base. It's 0.15. Want to find the number of moles. My volume, I will convert it to cubic decimeters, obviously, by just dividing it by 1,000. This will give me 0.02. So my number of moles, the number of moles which completely neutralize the acid, 0.15 multiplied by 0.02. This will give me the number of moles of barium hydroxide. This is 0.003 moles. Okay. The number of moles of barium hydroxide is equal to 0.003 moles. Okay, and then now we are asked to calculate the pH of the solution after step 1. Okay, they want us to find the pH of the solution after step 1. That means we must find the number of moles which were in excess in step 1. Are we together? How can we do that? I know that the number of moles that were in excess were completely neutralized by these number of moles. Why am I erasing now? Are you together? So I can simply say that I know that for me to completely neutralize my acid, I need 2 moles of my nitric acid to react with 1 mole of barium hydroxide. Are you together? But right now I do not have 1 mole of barium hydroxide. I have let me use a different color. Right now I have 0.003 moles of barium hydroxide. I want to know that how many moles of my nitric acid will I need. All I need to do here, guys, I'll just cross multiply. Whenever I cross multiply, I just focus on my coefficients. So x will be equal to 0.03 multiplied by 2, which will give me 0.06 moles. So these were the number of moles which were in excess in the first reaction, right? This x represent the number of moles of my nitric acid. Nitric acid is HNO3. This is 0.006 moles. Okay, I know the number of moles. I know the volume. I can simply find the concentration of the nitric acid in excess. How can I do that? The concentration of my nitric acid. The concentration of the nitric acid formula says C is equal to N over V. I know the number of moles, 0.006. My volume, my initial volume there, it was 25 cubic centimeters, right? So it's just 0.025. So my concentration, 0.006 divided by 0.025, this will give me 0.24 moles per cubic decimeter. Are you together? So this is the concentration of my hydrochloric acid which was in excess. Are you together? So now I can simply go and find the concentration of the hydronium ions. Are you together? I know that whenever my hydrochloric acid ionizes, I will have why do I keep on saying hydrochloric acid? Ascisin. Whenever my nitric acid ionizes in water, I will simply have H3O plus NO3 minus. Are you together? So which simply means that one nitric acid will always give me one H3O plus. So since my concentration is just 0.24 of nitric acid, I want to know how much of the hydronium ions will I form. Whenever I cross multiply, I'll therefore find that the H3O plus ions are the same as the nitric acid mole per cubic decimeter. Are you together? So now I do have the concentration of my hydronium ions. I can simply find my pH. pH is negative log of the concentration of hydronium ions. Negative log of 0.24. What do I get? Negative log of 0.24. This will give me 0.619. Let me just say 0.62. 0.62 is my pH. Are you together? Okay, the first thing I did, guys, was to find the number of moles which were neutralized by the barium hydroxide, right? Because I was told that the excess moles will then be neutralized by barium hydroxide, right? But in step number 1, the number of moles were in excess, and I know that for me to determine the pH, the substance which is in excess is the one that will tell me the pH of my solution. So now I know the number of moles in excess of my acid. I then found the concentration of my acid which was in excess, and then I use my ratio and proportion to find the concentration of the hydronium ions. After finding the concentration of the hydronium ions, I then calculated the pH of the solution, and then I got 0.61978 warawara. I just rounded off to 2 decimal places, which is 0.62. Are we together? Okay, and then now let's go to step number let's go to 7.3. Okay, the pH is 0.62, right? pH 0.62. Okay, the percentage purity of the M carbonate solid in the sample is 85%. We just need to identify substance or rather metal M. Ne? Remember that, guys, I just calculated that the number of moles which were in excess, we simply got 0.06. It's 0.006, ne? Yeah, we got 0.006 moles. These were the number of moles that were in excess after our acid reacted with M carbonate. Are we together? Now I want to know the initial number of moles of my acid. How many moles did I have? The number of moles initial of my acid. What do I have? I have the concentration of my acid and the volume. So I'll simply multiply the concentration and the volume. The concentration is 0.4, multiply, my volume is 25 cubic centimeters, just convert it to cubic decimeters, 0.025. So 0.4 multiplied by 0.025, this will give me 0.001. No man, this is 0.010 moles. Are you together? This is 0.010 moles, or you can just leave it like this, 0.01 moles. So therefore I want to find out the actual number of moles which reacted with the metal carbonate. So the number of moles which were used, or let me just say reacted, is equal to the number of moles initial minus the number of moles in excess. So I'll simply have 0.01 minus 0.006. This will give me 0.004 moles. So I now know that 0.004 moles of the acid completely neutralized my metal carbonate. Are we together? So I can calculate the number of moles of the metal carbonate. Are we together? And remember that, guys, the acid will only react with the pure part of my metal carbonate. Are we together? So I'll simply say that my metal carbonate, I know, let me see the ratio. I know that 2 moles of nitric acid will react with 1 mole of my metal carbonate. Are you together? So if I have 0.004 moles of nitric acid which are needed to neutralize the metal carbonate, I want to know how much of the metal carbonate will I need. I'll just cross multiply here. Whenever I cross multiply, I'll focus on the coefficients. So I'll simply have 2x is equal to 0.004, then x is 0.02. Remember that x simply represents the number of moles of the pure metal carbonate, 0.002. moles. Remember that the acid will only react with the pure number of moles of my metal carbonate. Are we together? So for me to find metal M, what do I need to do? For me to find metal M, I'm given the percentage purity, right? So I can simply say for the percentage purity, percentage purity, guys, you can use the mass of your element, or rather the mass of your substance, or the number of moles of your substance, right? Percentage purity is always number of moles of pure substance all over the number of moles of impure substance multiplied by 100. I know that my percentage purity is 85%. The number of pure moles is 0.002. The number of impure moles, I don't know that one. I'll multiply by 100. I'll just do my mathematical gymnastics here. I'll simply have 85 multiplied by the number of impure moles. 0.0, okay, I'll simply have 0.002 multiplied by 100. Whenever I divide both sides by 85, I'll get my number of moles impure. Yeah? So 0.002 times 100 divided by 85. The number of my impure moles, I'll simply get 0.00. It's too much because I don't want to round off. The number of moles impure, let's just say N is equal to 0.002 235294117. Okay, these are the number of moles of my impure substance. Are you together? Remember that I was given the impure mass. For me to identify metal M, I must know the molecular mass number, and then I can simply identify metal M. So I now have the number of moles which were impure in the solution. Are you together? But I do know that number of moles is always mass all over the molar mass. Are you together? Right now I do have the molar mass. I want to find the molar mass. So molar mass will be mass divided by the number of moles. The mass was 0.198. The number of moles is this one. So I'll just write N because I'm lazy to write. So therefore my molar mass is equal to, let me check the mass. Yeah, it's 0.198. Okay, 0.198 divided by the answer, I'll simply get 84.15 grams per mole. Okay, 84.15 grams per mole. Okay, now let's go, guys, and check. We have metal carbonates. I don't know what M is. I know carbon, the molar mass number for carbon is 12. The molar mass number for oxygen is 16, but I have 3 of them. So I'll simply say 16 times 3. This should be equal to 84.15. Are you together? So 84.15 minus 12 minus 16 times 3. This will give me M to be equal to 24.15 grams per mole. For me to identify M, guys, I need to find a metal with a molecular mass which is closer to 24.15 grams per moles. 24.15 grams per moles. I'll just need to go to my periodic table. 24.15 is magnesium. Magnesium is the only metal that is closer to 24.15, because these are the metals that are there. Man. These are the only metals that we have. Are you together? And the only one which is closer to 24.15 is magnesium. So metal M represents magnesium, guys. Metal M represents magnesium. So therefore M is equal to magnesium, Mg. So that means this compound is just MgCO3. Are you together? Okay, let's go back, guys, and check what did we do. First, remember that we calculated the excess number of moles in this in question 7.2.2. Are we together? I took it and wrote it there. Secondly, I calculated the initial number of moles of my metal carbonate. Are we together? But remember that the initial number of moles represent the impure number of moles. Are we together? Okay, I do have my initial. I know that as kids, guys, this one is for the acid. This is the initial number of moles of the acid. This is the this one was the excess number of moles of the acid, and then I calculated the number of moles which actually reacted with the metal carbonate. I got 0.04. Number one. And then secondly, I know that this amount is the one that will completely neutralize the metal carbonate. I want to know how much of the metal carbonate will I need, and then I found out it's only 0.02. Are you together? However, the hydrochloric acid will only react with the pure metal carbonate. It will never react with the impure part. So I know the number of moles which were pure. These are the number of moles which were pure. Are you together? But I was given the percentage purity. I used the percentage purity to find the impure number of moles. This was the impure number of moles. Are you together? And then after finding the impure number of moles, I was given the impure mass. I have the impure number of moles. And then I used my formula to calculate the molar mass of the substance, which is M carbonate. Are you together? After finding the molar mass, and then now it will be easy for me to identify which metal is represented by compound M. Are you together? Because I know that for my carbon, whenever I sum up the molecular mass for my elements, they must always give me 84.5. 84.15 rather. Are we together? So I know that the molar mass for carbon is 12, for oxygen is 16, but I have 3 of the oxygen. So I added the 2, and then I found out the molar mass for compound M is 24.15. Then I went to my periodic table and checked which element or compound is closer to, it has a molar mass which is closer to 24.15. I found out that magnesium is the one which is closer to 24.15 grams per mole. That's how, guys, you would have calculated or maybe identified metal M. If, guys, there are misunderstandings, please don't be shy to raise your hand. I'll come to you. I'll come to you. Okay, thank you, guys, for your time. Make sure you subscribe, you like, you share, and tell your peers to come join us. Senze izinto ezimnandi. Bye bye.